chapter, notice that we do have 4 standards. All right. Kids tend to do a pretty good job with all of them. It's something very different from linear. It's also different than exponential. This is a little bit different type of graph. Okay. What I want you to do right now is in your notes in your iPad, just kind of take them off to the side, and I want you to go to Google, and I want you to look up like parabolas in everyday life, pictures of parabolas. But I want to see them in everyday life, because a lot of times, where do you see parabolas? In math class, in science class. No duh. Okay? Now, let's brainstorm a little bit here. Where do we see parabolas in everyday life? Yes. Roller coasters. Okay? Shh. Yes. Eiffel Tower. L-E? Is that right? Or is it E-L? I think it's E-L. Eiffel. E-L. Is it L-E or E-L? L-E? I had it right the first time. All right. All right. What else? Yes. McDonald's. What else? Yes. Slinky. I love Slinkies. They're so cool. All right. Yes. Mm-hmm. Dolphins. Jumping. Yes. Bridge. Okay, what else? Rainbows. Yes. Okay. So building, architecture, parts of a building. Parts of buildings. Yes. Satellites. So things in space, because there's lots of things in space. Okay, yes. Arch. In St. Louis. Right? Yeah? Yep. Yes. Banana. Okay, yep. Angry Birds. Yeah. So in video games, right? And it does make a difference, doesn't it, at the arc at which it goes? Yes, it does. Yeah. Water fountain. Okay, I think we got a good fountain. So why do we study parabolas? So we can be really good at video games. Some of you, whatever works, right? Yeah, whatever works. But really, why do we study parabolas? They're everywhere. Absolutely. They are everywhere. So that's why the state of Minnesota says that we need to study them, because they're everywhere when you least expect it. In fact, if you look outside our window right now, you're going to notice that we have a house. See the blue one across the street? I see a rectangle. I see exponential decay in the roof. Do you see it? On the edges, do you see that kind of slope, that kind of curve? Do you see there's the rectangle window, but right up above it, do you see the parabola? Do you see it now? Probably didn't see it before, probably didn't care before. Notice now that we're seeing parabolas. Also, there's a circular window up in the Widow's Peak. Do you see it? Yeah. So shapes are everywhere. And when you buy a home or you design a patio or you have landscaping, you want it so that when you look at it, you go, yeah, that's cool. I really like that. Okay, that's math, guys, right? especially parabolas. We see them so many places, and that's why we do it. All right, so you're going to notice that we're going to look at one type of equation today. It is the y equals ax squared plus c. So I'm going to make this off to the side so you can see it. There is another equation for parabolas. It looks like this. Okay, what's the difference between the two? There's a bx, right? We're not going to do that one today, the one with the bx, because it does something to our parabola. We're going to look at the basic type of parabola, okay? All right. In our book in 628, you can look at this tonight. We're going to do kind of the meat and potatoes of this, right? The thing that I have up on the smartboard is called a parabola. Notice that it's U-shaped. It's not V-shaped. It's U-shaped, and it's got to be U-shaped, all right? Notice it kind of looks like an umbrella. Do you see that? The vertex, if you look at it right at the bottom, it's that dot. That's where the umbrella meets the handle of the umbrella. You know what I'm talking about? If you think about a parabola, that's where it's attached. That's the vertex. It's kind of the start, I call it, of the parabola. You got to start it there, and then you can make it wide. You can make it, you know, skinny. It can go move up. It can move down, but that's where you start it at. Okay? Notice that the axis of symmetry cuts that parabola in half. It's like the handle of your umbrella. Now, if you remember in elementary school, remember when you had a sheet of paper and you fold it in half and you painted your hand a certain color and you smushed it down on half of the piece of paper, and then you took that paper and you rubbed the sides together and you opened it up? Remember that? You made this pretty butterfly, and it's like, ooh, my butterfly's this color, my butterfly's that color, and you're all excited, yeah? Okay, the fold in the middle of your butterfly is an axis of symmetry. So in elementary school, they were teaching you line of symmetry way back then, and you didn't know what you were learning. Okay, same type of thing goes for a parabola. What you have on one side, you're going to have on the other. Your parabola should never do this, ever. If you did that, you did something wrong, okay? It should never be, oh, no, it's not going to spin on me. It should never be like that. It should never be at an angle like that, okay? Your parabola should never do one of these. Okay, it should be symmetric. It should be very uniform, right? One student last hour tried to make a real pretty parabola and did one of these. Don't do that, okay? For our purposes, a parabola is U-shaped and the sides go up real nice and even, okay? Questions? All right. Let's look at this problem. This is going to be similar to the one that you see in your homework today. So you want to take really good notes, right? It says graph the function and compare it to the parent function. And notice that I have some steps for you. Now you did this with linear. You also did this with exponential. So the first thing that we're going to do is we're going to make some tables. I'm going to do mom and dad first. So this is the parent. Okay, think of it this way. Mom and dad, curfew's 10 o'clock. It's always 10 o'clock. It's not 2 o'clock. It's not midnight. It's 10 o'clock. It'll never change. The parent graph of this will never change. And so if you want to do it in pen, do it in pen because it'll never change. It's always the same on every single graph when they talk about the parent, okay? What numbers would I plug in here? 0 and -1 and just like exponential linear, okay? So all that hard work is paying off. I'm going to put in -1. What do I need to make sure happens to that -1? It needs to have, has to have parentheses. Why? because you have to keep the negative inside. What's negative 1 in parentheses squared? It's 1. Okay, and then I'm going to plug in 0. Now 0 doesn't have to have parentheses, but I do it anyway, just to make sure that everything's covered. Okay, and that's the parent. That's mom and dad. And again, when you do this in your homework, you only have to make that table of values once. You don't have to do that for every single problem. However, when you graph it, you have to graph it on every single graph because you're going to do some comparing. Right? Let's look at the kid. Now, you need to show your work on this and show your steps. I had kids last hour, they're just like, well, I just don't want to. You're going to do it, so make sure that you do it because kids make mistakes. I'm going to put in the same numbers. What do I do first? Do I multiply or do I do the exponent? You do the exponent. Yep. So you need to show this step. I want to see that step. If I don't have it, I'm going to send it back to you and ask you to do it. Same with the 0. I know the answer ends up being 0. I get that, but I still want this step in there. Oops. That's right. Okay, now, before I continue with this, I want to show you something. Do you remember how I said on the parabola, what happens on one side has to happen on the other? Do you remember how I said that? Notice that I have a 1 here and I have a 1 here. Do you see that? That's a good thing. We want that to happen. If that doesn't happen, you did something wrong. Notice that I have a 5 here and I have a 5 here. That's a good thing. If you don't get that, you did something wrong. Okay, so you want that. Now it says to plot the point. So let's go to our graph. Here's the parent. Okay, and here's the kid. Now, when you draw the graphs of these, be careful, right? So here's the kid. It's going to be U-shaped, and I know it's kind of hard when it gets really, really skinny, but do your best. Here's mom and dad. Do not make them V-shaped. A V-shaped graph is absolute value graph. And you go, I don't get that. Let me show you. Y equals the absolute value of X is a V-shaped graph. So if you connect your dots in the parabola and make it V-shaped, it's wrong. It's got to be more U-shaped. Okay, think absolute value straight up and down, so straight sides. So don't do that. They're different graphs. Okay? Let's go ahead then and compare, because it says to compare the graphs. How is the kid compared to the mom and dad? It's skinnier, and we call that a vertical stretch. Yep. So if you remember when we did exponential graphs, remember we had vertical stretch or vertical shrink. Remember that? Vertical stretch or vertical shrink. Vertical stretch, remember, is when it's real skinny and goes up quicker. Vertical stretch is when it's fatter, right? And it's more open. So if it's more open, it's a vertical shrink. If it's more vertical and goes up quicker, it's a vertical stretch. Right, right. Okay. All right, that's it for today. So your assignment for today is going to be on page 632. And I'm going to do 6 through 9. That's it. We're not doing a lot today. And I'm going to get you started on the first one. So if you will, get your paper out, and I'll get you started.